This is going to be a quick demo of a scenario based on the exeutils exploit. What we're going to do is we're going to deploy a system under test to Kubernetes and EKS deployment. And what we're going to do is we're going to poke at it using a proof of concept for the exeutils backdoor. And what we're going to do is we're going to show how the Rampart agent can notify you and protect you from this specific exploit without ever having known about it a priori. And that's a pretty powerful capability. So let me go ahead and spool this thing up here. What I'm going to do is I'm going to deploy the exeutils Kubernetes descriptor. And you can see that it's sitting behind a load balancer, and we'll wait a few moments for that load balancer to actually resolve because sometimes they take a while. What I've got is two shells on the left. I have a dashboard that I'm going to show you momentarily on the right-hand side. And then I have this diagram right here that shows kind of the architecture of the scenario. So what we've got is clients, both good and bad, will interact with our endpoint through the internet. They hit an ingress node. In this case, it's just the load balancer. That winds up routing traffic to one or more of our pods. In this case, it's a much simpler setup. There's really only a couple pods in play here. And what we've got is also our Rampart container runtime security agent sitting inside of the EKS environment. And basically what it's doing is monitoring everything that happens there. And it tries to pick up on anomalies based on what it's learned about the way the system is expected to behave. So it's making system calls related to file stuff, network stuff, code execution. It'll be gathering continuously a living bill of materials for all the services that are running there, and also looking for published vulnerabilities and exposures about things that might be problematic. And it can also, use some other scanning capability out there to try to find things like misconfiguration and all that kind of stuff. But a lot of that is out of scope for the demo today. What we're going to focus on is code execution that happens downstream of exploiting the exeutils backdoor. So let's look at the Rampart dashboard here. This is where events are going to show up when bad things happen. And I have a couple of events here that were from previous test runs. And basically what we're going to do is we're going to show you as we walk through the scenario that when I interact with the endpoint in a malicious manner, you'll see these things pop up, and we can dive into the telemetry. So right now we've got a CVE detection and a telemetry health message, which are, in this case, relatively low severity. But basically, these are telling us that certain pods inside of the network are doing things we don't expect. And again, the low severity should indicate to you that they're not that serious. But one of them is that our agent hadn't responded in a while, and that's because I just rebooted the thing. And then the next one is that there's not any publicly available information about this Rampart AI private XZBot latest image. And I'll talk about why that is later. But basically, that's one that we rolled ourselves, and no third party has ever scanned it. So that's why there's no publicly available information about it. That's why. So what I'm going to do is I'm going to interact with this thing now that it's stood up on the left-hand side through the shells. And I'll periodically bounce back over here to show you interesting things that happen. And then I've also got a Elasticsearch telemetry shipper configured here so that anything that happens in our dashboard gets cross-shipped over to Elasticsearch. We could just as easily plug this into your SIM endpoint. It's very easy to do that, but Elasticsearch is also very simple. So we've got a Kibana dashboard fronting an Elasticsearch index, and that's where we're cross-shipping events when they happen. So let's go through the scenario. First thing, I'm gonna be kind of using my cheat sheet here. Some of these commands are a little bit convoluted. I'm just gonna make sure that DNS has resolved or is resolvable. Could be because I've been talking for a while, and there it goes. So the domain name of our load balancer is now mapping to an actual IP address. Next thing I'm going to do is I'm going to show you what a vanilla SSH into this environment looks like, and this shouldn't really do anything because it's benign. So what I'm doing is I'm setting this XZY endpoint variable using some kube control stuff to look up what that load balancer's address is, because it's kind of hard to keep it in mind. It's a very long random string. So I'm going to fire this thing off, and I get a warning about this being a new host because this gets created every time I run it. And then I get to the logins. I'm not actually going to log in right now because I'm just trying to kind of like knock at the door. So this represents the use case where I'm a bad guy, I don't know the environment, and it will kick me out if I don't have the password. I'm putting in a couple of intentionally fake passwords here and getting kicked out. All right, so that's the intended behavior of the system, and Rampart correctly identifies that nothing anomalous is happening there because you very much want your endpoints to be kicking out bad guys and not letting them in, right? So that's all well and good, but this is where it gets interesting. What I'm going to do is I'm going to fire up this XZ bot. You're going, oh, we just got a CVE detection in high severity. And this happens periodically. It's not necessarily by virtue of anything that's happening here. But this one is juicy. It says that it found a critical vulnerability, which in fact, this is the XEUtils CVE in this Team Nautilus XZ bot image, and a description of what's happening and a link to go learn more about it over at NVD. So this happens asynchronously as the system is scanning your endpoints, kind of serendipitous that it happened here like that. But let's go on and run the actual exploit now. So we go back to my cheat sheet here, and let's check out what happened. Take off this XZBot utility. And this is a third-party tool that's part of a proof of concept. And it kind of represents the exploit piece of this equation. And this is actually running outside of our Kubernetes environment. You saw that I'm running this directly through Docker. And we are referencing the Kubernetes endpoint via its load balancer URL. So this thing right now has initiated a connection to the server that's going to do something horrible. And the something horrible here is a netcat LNVP, tac even bash. So it's sitting there waiting for an incoming connection. And when it gets a connection like this, so it's a bind shell essentially. And when I netcat into that endpoint, something bad's going to happen here. And it's not immediately obvious that I've exploited anything, but I do a who am I. And you saw like right when I kicked this off that we got some telemetry, and we'll look at that in a moment. Just putting in some kind of silly stuff here. All right, so we got a command and control on this box via the XEUtils backdoor. We can see that there's telemetry that pops up when we do that. We can also get a pretty interesting view into what's actually happening. So here we see the who am I. You see all kinds of additional information about what privilege. Just kind of try to grok this for a moment. Some of these are entry points, some of them are exit points. This is all based on some call telemetry being emitted by a sensor called Tetragon, which is using eBPF to capture system calls related to process execution. But we're really agnostic of that. All we care about is that you have some mechanism of identifying those things, and there are various ways to do that, like for example with audit-D. Okay, so we got all of our commands. We picked up on the netcat spawn, and we've identified where the badness is happening here. So that's good. That demonstrates that we're able to detect it. Now, a couple other things I want to show you here. Let's go check out our image inventory, and this is kind of like the living document that really shows you, like a dashboard of what's been deployed. We have this notion of a workspace. I'm not going to talk too much about that, but this is essentially a workspace specifically for a number of pods that run in our demo environment. There's not a lot of them. You can see there's two different Nginx images. There's a Quake stack, which is a demo for another day, but it's very cool. We have this XZBot scenario, which is the one we're running now. And of course, we have our sensor itself. So nothing's picked up in our sensor. XZBot has this one really spicy critical vulnerability that we saw earlier. And Trayoder Quake.js has a lot. This is a really old image. And over time, you kind of accrete vulnerabilities. And so these have just kind of built up. Of course, this XZBot one will have more of them as we move forward in time. But for now, it's got this really, like I said, really severe critical XEUtils backdoor inside of it. And that's the one that we just exploited to break into the system. Now, there's a couple different ways of looking at the health of your environment. And the one that I just showed you, of course, is this event timeline. And that kind of shows you over time what kind of events are happening inside of your system. You can also look at it in a context-oriented manner. So before I showed you that there were a number of different pods involved in our workspace, but really we also provide an abstraction called a context, which is kind of a use case for a number of those pods. And in this case, our context is XZY. And you can see the number of things that have happened over time. There's this little blip here from where, from before I started recording. But the bulk of this stuff has happened since I started recording this video. You can also look at the images over time and see kind of what's happening inside of images and get a view there. And you can also look at a run-oriented view. And there's a lot more of these because I've been doing work here over time. So again, the cool thing here is that we have this living inventory of what's running inside of your environment. It's kind of an accumulated static view of what's ever been executed. And then we have these runtime dashboard views that show you kind of what's happening on it as a timeline. And then you can download bills of material in different formats. You can download the CVEs in a more formal, robust format if you want all the gory details, and there are quite a lot of them. Some of these artifacts can be a couple megs in size, especially for larger and more complex containers. So anyway, that's it. That's the demo. That's how Rampart can protect you against a very serious threat that recently happened. And again, it does this in a way that is completely agnostic of anything that's specific to XEutils. Of course, we can scan the image and say, hey, that's got some vulnerability and exposure cross-section to it. But the more interesting thing is dynamically using the system calls that we observe inside of the container and comparing that to what we expect to happen. And whenever there's a deviation, we can flag that. So without necessarily knowing that some of those bad commands that we're running were caused by XEutils, we still flag them as problematic. That's a powerful concept because it doesn't require that you know all of the supply chain vulnerabilities and all of the means by which you're going to be exploited. There are tools for enumerating those and protecting you against them, and we very much recommend that you continue using those tools. But clearly, we need something a little bit better to protect us against sophisticated threats that are going to pop up, especially in kind of supply chain kind of scenarios. So that's it. That's the demo. Thanks for watching.